Hi, hello everybody, and welcome to the finale of chapter 4. So we have talked about a ton of concepts, and we want to use today as an opportunity to review all the things we talked about. So as we get started looking at these examples today, we want to make sure that we're on track with our notes. We will turn those in as we finish up today, and be ready today for 10 examples reviewing everything we've talked about. So use these as an example for what you will see on your test coming up. So let's pay attention, follow these, work through the concepts, and understand them as we move forward. So our first example asks us to write an equation. Now you're going to see lots of problems on your test that ask you to write an equation, but you will need to pay close attention to what type of form you are asked to write it in. In this case, we see standard form, which we know means some number times x plus some number times y equaling a constant. So a, b, and c are all whole number integers, and we know a is a positive number. A can't be negative. We want a to be a positive value, so the x should be positive. Our x and y are on the same side. We talked about that many times. So standard form for a line that passes through this given point, that's an x and a y, and it has a y-intercept or a y cross. It crosses the y-axis at the value of 2. So given all of that information, let's try to write our equation. So let's think about, what do we know here? Well, our y-intercept is 2. That is our b value. B is 2. So we can start with y equals mx plus b, and we can use that to find our slope. So we can plug in what we know here. We know several things. So first we know b, that value is a 2. We know an x, because we have a point, that's 7. And we know a y value, that is -3 given. So we have 3 things, there's only one missing, so we can find it if we want to. So let's plug in what we know and then get closer to solving this. So y is a -3, m we don't know, x is a 7, and b is a +2. So how do you start? Plug in everything you know. From here we know we need to solve for m. Oops, this should be a 2, not a b. This is a +2. From here, we plugged everything in. We want m by itself. So let's subtract away the 2 from both sides. This goes away. On the left, we get a -5 equals m times 7, or 7m. Now to get m finally by itself, what must we do? Well, we see that this is tied by multiplication, so we will divide on both sides. These 7's go away, and m equals this value, -5/7. So that's our m value, but we're not done because we need to write our equation in this form. So we could say we know y equals that m value +2. How did I get this? Well, we know b is 2, that goes here. And we know m, we just said, is this value here. But we want to write it in the standard form. So let's get x and y on the same side. So I'll add 5/7x to both sides. Since this one's negative, I want to add. If I do that on both ends, what am I going to see? Well, on the right, this cancels out. And on the left, we just add these two together. So we have 5/7x plus y equals a +2. So we're almost there, but not quite, because a, b, and c in the standard form need to be whole numbers. So how can we make all these whole numbers? In other words, how do we get rid of the fraction? Well, we can do that by multiplying and getting rid of the denominator. So if we actually multiply everything by 7, that will cancel out our denominator. So we'll multiply everything here by 7 and everything on the right. So with that step in mind, and with some simplifying, what will we get? Well, the 7's here cancel out, so we'll get 5x. 7 times y is just 7y. Notice I'm applying the 7 to everything, not just one term. 2 times 7 is 14. So, do we have x and y's together? Yes. Is the x value positive? Yes. Do we have whole numbers for all three? 5, 7, and 14? Yes. So our standard form, final solution for example 1, 5x plus 7y equals 14. So have that piece down as we continue. So example 2. Here we want to write the slope-intercept form of the line that we see here. So slope-intercept. There's the form that we're keying on for this one. We know that means y equals mx plus b. So since this is what we're looking for, we know the two things we must find are m, the slope, and b, the y-intercept. So what is my y-intercept? Where does this line cross the y-axis? Well, we see that point is right here. And what is the value of this point? We'll say -1, 2, -2. So we know b is given by that value, a -2. But we also must find the slope. So how can we do that? Well, we can pick 2 points and then plot the change between them. So here's 2 points. I see a rise of 2 and a run of 3. So my slope is rise over run, so 2 over 3. In other words, my slope is actually a 2/3. So given those, we can just plug those in here and here, like we've done in the past, and get that equation. So y equals, we know it's y equals m x plus b. M we said is 2/3, so I'll write that in. As I change my color, notice as I sub in, we'll get close to our final answer. But there's one more thing we want to do to write this as best we can. We would never write plus a negative, we would just write minus. So instead of plus and -2, I'll just put a -2 there. So final answer, y equals 2/3 x. This is a 3, 2/3 x minus 2. Slope-intercept for example 2. Now example 3, here we want to write that equation in slope-intercept form for a line that passes through these 2 points. So my first step will be to find my slope. And I know that my slope is the difference in the y's, so if I start here, 4 minus a -2 over the difference in my x's, 3 minus a -1. So what will I get here? 4 plus 2 is 6. 3 plus 1 is 4. If I simplify that, they're both divisible by 2. 6/4 is the same as 3/2. So that is my slope. That is my m value. But we need to write that equation in slope-intercept, which we know means y equals mx plus b. So we found m, but now we need to find b. So in order to do that, we have to plug in a couple things. So I know m is 3/2. I'll put that where that goes. So now we're looking at this. To find b, we need to plug in the two unknowns, x and y, and then find it. Do we have x and y somewhere lying around? Well, yes, we can pick either point here, plug in those values, and solve for b. So let's just say we plug in 3 and 4 to just have positives. So the y value is a 4, the x value is a 3. So 4 equals 3/2 x, x in this case is a 3, plus b is what we're looking to find. Now how do we get here? Next step, we'll multiply these things and simplify. So 3 halves times 3 is 9 halves. And I'm going to rewrite 4 in terms of halves. So 4 is the same thing as 8 halves. Now I want to subtract away this fraction to get b by itself. So if I subtract 9 halves from both sides, this one goes away. Over here, 8 minus 9 halves will be a negative 1 half. So b is actually negative 1 half. So that is my b value. My m value is here. So to finally write it in slope-intercept form, we know y equals mx plus b. So what is m? M is 3 halves. B is a negative 1 half. So now to finally write our equation in simplest form, we know y will equal 3 halves x. Notice with plus and negative, we would just write minus 1 half. And that is our final answer for example 3. Y equals 3 halves x minus 1 half. So fourth type of thing for today. This one, notice it says, what is the type of form we want? Well, in this case, it is point-slope form. If we remember, that is y minus y1 equal to m times the quantity x minus x1. So all of these forms are in your notes in one section or another. It is useful to know these. Without that, you will not be able to solve these problems. So point-slope form, a line that has a slope of 1/3, that's my m, and passes through this point given, that's an x and a y to help us get there. So I can plug in the 3 things that I know. And the 3 things I know I'm going to circle in red. My slope, I know m is a 1/3. My y point given, I know is 8. And my x point given, the x1, is a negative 2. So substitute those things in and get our next step. So we know y minus 8 is equal to 1/3 times the quantity x minus a negative 2. Instead of writing minus and negative, I'm just going to put plus 2 because that's the same thing. Okay, so y minus 8 equals 1/3 x plus 2. Now this is perfectly done. This is point-slope form. There's nothing else we want to do here. We don't want to distribute this. We don't want to simplify. We want to leave it just like this so we can see the point and the slope. So point-slope form, you should remember you like those because they're shorter. So we are done on example 4. Y minus 8 is equal to 1/3 times the quantity x plus 2. So do remember this form and have that down. Remember that. Memorize that so you can do that form on your test. Okay, the next one we see asks us to write in slope-intercept, so we all know what that is. This tells us the equation is parallel to the graph 2x plus y equals 5. And it passes through this point given. So we know it's parallel to this graph, okay. But what is the slope of this graph? Well, let's rewrite this in y equals mx plus b form. So if I subtract 2x from both sides, this equation I can rewrite as y equals negative 2x plus 5. How did I get here? I subtracted 2x from both sides. So I have y alone, and I know the number now attached to x once I solve for y is my slope. So my slope in this case is a negative 2. Our line that we want to find is parallel to this one. So parallel we know means same slope. So the line we want has the same slope as this one. So in other words, our slope for what we want is a negative 2 also. So that's one valuable piece of information. Now to write the rest of our equation, we need to know what is our b value. So we know what we are looking for is y equals mx plus b. Now the things we can sub in, I'm going to circle in red. We know our y value, we can put a 1 that goes from here. Our m value, we know we can plug in a -2. We already found that. And our x value, we can plug in here. That is a 0. So we can move all these letters, change them to numbers. There's only one thing left to find, that's our b, and then we'll be able to write that equation. So let's do that. So 1 equals -2 times 0 plus b. -2 times 0 we know is 0. So b, add nothing, you'll equal 1. So what is b? Well, b must equal 1. Now if this is true, we know the final step to write our equation. We know we need y equals mx plus b. So let's substitute in the two values we know are true. M is a -2, so I'll put that in this slot that it goes in. B is a +1. So there's our equation. Y equals -2x plus 1. That is in slope-intercept form. So have this piece down for example 5. Y equals -2x, add 1. Okay, so the sixth type of example, similar to the one we just did, but this time we want it to be perpendicular to the graph that we are given. We again want slope-intercept form, so we'll see that. Now what is our given graph? What is the slope of this one? Well, we see y equals -3/2 x minus 7. So we know when it's solved for y, the number attached to x is our slope. So in this case, the number attached to x is a -3/2. So this number is our slope of the line given. But the slope of the line we want is actually perpendicular to this one. So what is the rule for perpendicular slopes? How do we find the slope that we want? Well, we know it is the negative reciprocal of this one. So if we're given -3/2 is the slope of the line we see, what is the slope of the line we want? Well, we know we should flip it. That would give us 2/3 with a negative. And then we want to change the sign. So instead of a negative, it should be a positive. So we'll leave that positive. So this is the slope of the line we want, a positive 2/3. And we can check to see that this is true if, in fact, these multiply to give me -1. So if I did this, I would get a -6/6, which divides out to be a -1. So since this is true, these slopes are perpendicular, so the one we want is a positive 2/3. So 2/3 is the slope we want. And it passes through this point given. So that's an x and a y. So now we're getting really close to writing our equation. So we know very well now slope-intercept. Y equals mx plus b. So let's plug in the things we know. M is a 2/3. X is a 3. Y is a -2 plus b. Okay. So to get b alone, we'll multiply here. This will give me a +2 when I multiply. On the left, we still have a -2. To get b alone, we'll subtract 2 from both sides, and b will equal a -4. So b is that value. So to write my final equation, what do I get when I plug in m and b? Well, we know y equals 2/3, that's my m, x, and then my b is a -4. So y equals 2/3 x, take away 4. Have that for example 6. Great, we were rocking and rolling, working on these, reviewing these concepts, feeling good about it. So next one, we recently practiced this, so this is fresh in our minds. We want to graph the inverse of the function we see. So in order to do that, We got to start by picking a couple points that we can easily discern. We can easily see what they are. So I see this one's on a corner, that helps me. This one's on a corner, that helps me. So let's use these 2 points, find these values, and then flip them around. So this one is the point 0, 6 in my original. I also have the point 6, negative 2. If you're confused on how I'm getting these values, each box counts as 2, not 1. So this is 6, this is a negative 2. So we have that as our second point to focus on. Now we know to get our inverse points, we must do what? Switch the order. So as I switch my color as well, let's flip these around. We get 6, 0 and negative 2, 6. This is a 6. Okay, so we flip these around. Now we're going to graph these new points. This is going to be my inverse, and this is my original. So plot these points. So 6, 0. Go over to 6 and stay there. And then my second point, go back 2 and up 6. Now you want to connect these points with a line. So if we do that, it should look something like that. So we have a line going across, and we can see, I told you as a way to check, you should see if it is symmetrical about the line y equals x, just a diagonal line going perfectly up and across your graph. So we see that this is indeed symmetrical. We could fold it along this line and they would meet up perfectly. This is our inverse, given those points. So take some points, flip them, plot them, draw your line, and then you'll be golden on these types of examples. So have yourself that image as you move to example 8. Okay, for this one, you want to write this equation. Notice it says standard form. So we practiced that. We know what this means. But let's pay attention to what is given in our example. They tell us it has an undefined slope. Undefined. So undefined means a line that goes vertical straight up and down. Something like this. Now we said lines that are either vertical or horizontal are a special case. They're either y equals a number or x equals a number. So undefined is that x equals when it's vertical or y equals. Well, if you can't remember, I told you this, every vertical line is x equals some number. So we know our equation is actually just going to be x equals some value. They tell us it passes through the point negative 6, 4. So this is a negative here. It's just cut off on the right over here. So it passes through the point negative 6, 4. So in other words, what value of x is true for this point? Well, the x value is a negative 6. So what must the equation be if it's x equals a number and the x value in the point we have is a negative 6? Well, our equation has to be x equals negative 6. That is the only thing possible. So anytime you see something undefined, it's x equals a value, in this case a negative 6. So shorter equation, it's in this form because there's only one x, it's positive, there are no y's, and it equals some number. So this is perfect for example 8. So the ninth one today, if our function is equal to these numbers given, we want to find the inverse function. So again, this one is fresh as well towards the end of the chapter. Given this equation, we'll find the inverse. So let's start. First step, change f of x to y. So y equals this expression divided by 15. Good. Now we want to find the inverse. So let's now change x and y. We'll switch those around. So if I do that, x equals, notice what's happening. We changed the x and the y. They're in different positions. Good. Now to find that inverse, we need to get this y value on the right all alone. Get this by itself. So to do that, we'll multiply both sides by 15 to start. So here, this will cancel out, and over here we'll get 15x. So 15x equals 5 minus 4y. Looking good. Now next step, we'll subtract 5 from both sides. So that will eliminate the 5 on the right. And one final step to get this y alone, get rid of the 4. It's a negative, so we'll divide both sides by -4. So we know y will equal 15x minus 5, all that divided by 4. Now you could leave it this way or split the 4 and divide both of these by 4. Either way is fine. But as the last step, we know we don't want the y. This notation isn't good. We want to use the inverse notation that we talked about. So that's our f with a little -1 of x is equal to everything on the right, 15x minus 5, all divided by 4. And there we have our perfect inverse function. So that should make some sense for example 9 as we finish this up and close this chapter. One more quick one to look at. We can do the inverse function of this example as well. So let's quickly do that. So to do that, we'll switch x and y. So if we do that, 6y plus 8x equals 13. Get y by itself, so we will get 6y equals -8x plus 13. And if we divide all that by 6, we will have this expression here. This 6 will get divided away. But remember, we don't want y equals, so instead of writing the y, we will write f of -1x is equal to all of this on the right. So this is our expression here. Our inverse, f of -1x, is equal to -8x plus 13, all divided by 6. So hopefully that makes sense. We'll close this chapter, get ready for some study guide practice, and do well on our tests in the near future.